In fact,
This meeting is being recorded.
all right, good evening, everybody. Welcome to tonight's, or I guess evening here, but might not be evening where you are. Welcome to today's vertical focused meeting. Today we're talking about topics related to LLM development. And for the first topic on our agenda, we have listed a Web LLM version 1 roadmap. I believe, Charlie, that is your topic. Is that right? So please
Yep.
introduce it.
Oh yeah. So I just start. Let me try to share my screen. Okay. Can we see the screen?
Yes, thank you.
Okay. Yeah. So hi everyone. My name is Charlie, and I am a master's student at Carnegie Mellon, working under TQ's group. And more recently, we've been making a push on the Web LLM project. And so for the agenda, I can first kind of go over what Web LLM is, its overview, and the current stack it's using. And then I will give some current status and more recent updates on the project. And then we can talk about some of the roadmap, including the OpenAI API compatibility, supporting more modalities, and finally developing like prompt plugins or agent assistant building on top of the WebLM project. So yeah, so WebLM is an application or a project that allows you to run large language model completely locally inside your browser and leveraging acceleration from this backend called WebGPU. And essentially, WebGPU uses this language called WebGPU shading language. So it's kind of like the CUDA code for NVIDIA GPUs. We use WGSL. And a good thing is that it doesn't matter if you're using a MacBook or Windows or even recently Android, you can all leverage WebGPU, which kind of provides a natural abstraction layer for both users and developers. And it is currently enabled by default in Chrome, and you can check your own device or browser support inside this webgpureport.org. And for the WebLM project, the kernels we use are compiled through MLC LLM, which is another project built on top of TVM as a backend, and leveraging Relax. And some of the runtime support for WebLM is supported by TVM.js, which is the web folder under the TVM repo. So yeah, this is a high-level view of the stack of WebLM. And for some recent updates and current status, by recent, maybe like the past 3 or 4 months. So for WebLM, we've been pretty much treating it as a test bed for the new release of language models. For instance, we recently supported Phi, Mistral, and Words of Math. It's been used like a platform for where users can try new models or model releasers could demo their models. For instance, when the Wizard Math version 1.1 came out, we only spent like 20 minutes to support it in WebLM. So it was a pretty, I think it's a pretty efficient way of demoing new models. And we've also seen other people in the community using WebLM as a backend to launch their own applications. For instance, there is a project from Georgia Tech, I believe, called Workflow, where they basically developed a in-browser application for editing text and doing other text-based tasks. So yeah, and like I mentioned, Android recently supported WebGPU by default in the new version of Chrome. And as you can see on the right side, this is running WebLM 4-bit quantized Phi inside a Samsung Galaxy S23. And yeah, and I believe in the future, more devices are going to be supported or even more browsers. And implementation-wise, WebLM migrated towards the new tvm.n module, which really helped streamline and modularize our model definition process. And we supported techniques like attention sync, which is especially important or helpful for restricted environments like web browser, where you could essentially, even if the KV cache, say, is like 2048 sequence length, but with like sliding window or attention sync, it could be increased to like 10 times more, theoretically. And also, we're currently migrating to a new KV cache interface in Relax. So as we can see, I think for the current status, we've mostly been using WebLLM as a platform for chat demos. So for next step, I think the goal is to make WebLLM more than just chat demos with new language models. So with that, we are going to talk about our roadmap. And in order to support more features, we think it's important to develop a consistent line of APIs. And as the OpenAI API have been more and more popular and adapted by different inference platforms, we think it might be a good idea to support OpenAI-like APIs. So for instance, on the right side, we have the OpenAI node, which is basically their JavaScript and TypeScript version of OpenAI library, where they just called openai.chat.completions.create. And we can have a very similar user experience on the left side with WebLLM. And this is essentially JSON in and JSON out. And this can help structure the user experience a lot. And with that, this is just chat completion. And after defining the OpenAI API, we can move towards more modalities. For instance, we could have visual question answering models such as Lava. And with the new API, it's simply going to be another content inside the messages. As you can see, you can embed an image URL here. So yeah, and there's another thing called Gradio Lite, which is a relatively new feature from the Gradio team, where you can directly run Gradio inside the web browser. For some background, Gradio is, from my understanding, is essentially providing a library for the user interface for large models. And I think for like multimodal models, it could be especially helpful. So yeah, and besides vision as a modality or some other modules we could look at, could be, for instance, an embedding module. There's a recent embedding model released by Nomic. And we could, instead of using, as we can see, instead of using a chat module here, we could perhaps substitute it with an embedding module. And the workflow for the user is going to be very similar, where they initialize a different module and still call the same reload and use a very similar input structure. And also very similarly, we could have a audio module for perhaps supporting models like Whisper. And this is a demo from the transformer.js project, which is doing something somewhat similar to WebLLM, except from my understanding, they are not using WebGPU yet. I think they're using Onyx for runtime. So yeah, but I think they have a lot of features that we could perhaps play a bit of catch up here. For instance, the Whisper could be something that we can support in WebLLM. Yeah, so the high-level idea here is that currently we are only using the chat module in WebLLM, and in the future, with the OpenAI API landed, we could support more modules and therefore more modalities in an extensible manner. And yeah, and another item that we've been brainstorming about is the making WebLLM make WebLLM a backend for browser plugin, like Chrome plugin, Chrome extension, essentially agentifying the project. And there's a recent project done by another folk at CMU, Sudeep. It's called MLC Assistant. As you can see, this demo, it is interacting with the overleaf, highlighting the text, and then prompting the model, and the model is giving back some feedback on the person's input. And it's currently using a REST API with a local server, meaning that you have to, for instance, if I'm using a Mac, you have to set up MLC inside the Mac and then launch the compile the model or run the model inside your Mac instead of only using a web browser. Therefore, next step could be to migrate this repo to use WebLLM and make it much more lightweight so that the user do not have to do any setup. They just open up a browser and then the browser is going to take care everything for you. And some potential challenges include currently there's an issue here where people are complaining that the web GPU API is not supported in a service worker in browser yet, meaning that there could be some challenge to let the worker persist across pages when it's being used as an extension. And some other challenges include there could be different ways to interact with the document for different tasks. For instance, Gmail, Overleaf, Google Doc could all have like different DOMs. So it could be a challenge to abstract out the interaction with different pages, web pages. And it's only currently text for now, but we could imagine in the future, perhaps it could be other modalities involved, such as maybe even with Google Calendar, etc. So yeah, and the high level goal is that we want to make WebLLM more than just chat demos with language models. And that's pretty much it. Yeah. And are there questions or thoughts on discussion?
Wait, could you possibly comment more on MLC Assistant? So you said it's not currently using WebLLM, is that right?
Yes, that is correct. I believe it's currently using a REST API. Basically, you are launching a local server inside your own laptop, and then yeah, it's sending requests to that through REST API. Yeah.
Okay. But I'm curious about so the server it launches. How are the models implemented? Is it using some other service, or could you
Right.
comment?
The models are implemented, compiled through MLC LLM. So if you're hosting the local server on a Mac, you are going to use the Matto libraries. If you're hosting it with, say, NVIDIA, you're going to use CUDA, etc. Yeah.
I see. So the difference is this doesn't use web GPU. Is that
it
what's
doesn't.
important?
Yep. Yes.
Thank you.
I had a question about your embedding model slide.
Yes.
So I don't know if this applies to WebLLM, but I've been trying to get the E5 Mistral up and running with MLC AI, and I realized the neural architecture, it like shaves off the 2 layers. And it's been kind of challenging to work through that. Is this going to be like an embedding module per embedding model? I don't really know how to frame my question.
Right. So this is still a high-level idea for now. I think the embedding module is going to be similar to the chat module on the abstraction level. So we might still need to, for each model, we still might need to have their own implementation if the architecture is different. What was the model you were mentioning, E5?
Yeah, it's the E5 Mistral. So basically,
Like EE5?
yeah, and that should load it up for you. So
Ah, I
it's
see.
that like embeddings by language models paper. But if you go
Right.
to the like files at the tensor index or the
Config?
model.save tensors index.json, it misses like the first top two that Mistral already had. So I
I
couldn't use it
see.
as like the same Mistral like Python class that was built. And I started trying to build a new one.
I see.
But
I
then
see.
I get errors like model.layers is what's needed, but then like model.embed tokens wouldn't work.
I see. Maybe you could submit an issue and then we can take a closer look offline if that's
Okay, but
okay.
short version of my question is like that
Yeah.
your embedding module wouldn't tackle that, right? This is like a per
Yeah, I
model
think I
class.
think that would be
I
a
see.
different issue. Yes.
Thank you.
Yeah.
Any more questions? Okay, if there are no more questions, then we can move on to the next item in our agenda. Thank you very much, Charlie. The next item on our agenda is MLC Serve. Who added it to the agenda?
I added it, but I think Rayhan is going to take care of it.
Okay, by all means.
Okay, I guess you can now see my screen. And thank you, Stephen, for introducing, and thank you, Charlie, for the great presentation of the overview of WebRun. And for me, I think this would be a very quick update of the MLC serve that we have been pushing in the past, I think, few months. And I remember in the last time when I talked about the MLC serve at this meeting, we mentioned that the serving is still in a separate branch, and we offer continuous batching. We aim to support the full OpenAI API compatibility, which Charlie just briefly introduced as well. And we also support like tensor parallelism to run the model on different GPUs, and we leverage the page KV cache to enable to do fast like attention computation without too much memory waste. And also we aim to offer the very good or the state-of-the-art performance here, and with multiple platforms supported across like NVIDIA GPUs, AMD ROCm platforms, Apple GPUs, and also like other platforms like Vulkan. And today, I think some of the highlights here would be these items in the bold. And firstly, a great thing is that we have merged the serving branch into the main branch. So right now, if you want to try MLC Serve, you don't have to switch or check out to the separate branch to build everything. And after that, there will be some slides talking about like some of the OpenAI API compatibility updates and some of the multiple platform support update and something related to the performance. And for the OpenAI compatibility, this is what we have for the OpenAI compatibility. You can see that there are so many like choices or options you can specify. And right now, MLC Serve has already supported most of them, but there are still some of them ongoing for being built. And for example, like the JSON format and the total cost, right now in MLC Serve, there is already some of part of the work regarding the JSON format, JSON grammar support that is already merged. And our team also have folks that is working on the function call or tool calls that basically allow you to require your model to generate something in some content in a function call format. And the next I'd like to talk about is like I think it might relate to Steven's your previous question about the REST API. For example, in like Charlie has mentioned, in the MLC assistant right now, it only uses the server that is locally launched throughout the previous REST API in MLCRM. And after I think in about like 2 weeks or so, we're going to deprecate the previous REST API support and switch to the current REST API based on the MLC serve. And that's basically, I think that will be a milestone after we align all our performance on the single sequence, so that so that we can have a unified REST API support and deprecate some of the existing code. And I think to that end, before reaching that end, we will also update the REST API documentation at this page. And right now, this page still refers to the previous REST API, but we will update it. And the next time would be the multiple platform support. I think last time, well, at that time, we are at a point where we only have NVIDIA support, but for now, we have already supported like NVIDIA or Apple or AMD GPU. This is done by some other folks in our team who enables the attention computation on some of the like platforms like Apple or AMD. This, I think this is like previously the attention computation, I think most of us might have known. The previous attention computation utilizes the flash attention or other forms of flash attention that are basically in handwritten QR codes. But right now we have bring the flash attention algorithm to our intermediate abstraction in TVM pipeline, and that enables us to compile the flash attention to different platforms like Apple or AMD. And yes, and moving on, we are moving towards more model support. And right now, I think one particular thing I'm very happy about is that to use MLC serve, you usually only need to you only need to compile the model once. Basically, you just compile the model same as if you are going to use MLC chat or the already existing functionalities, and you only need to compile the model once, and no need to compile them separately. And these, I think, are basically benefited from our new M module framework called Slim. And right now, the MLC serve, I think we basically support Llama family, and I do know that some folks in OctaML have been working on extending the MLC serve to other models like Mistral, and we will bring more models to the MLC serve with the batching attention computation support. And yes, and finally, I think it is about the performance. And from our data that we have already collected so far, we can have about like 10% or better, both throughput or latency on 70 billion Llama 2 than the VRM baseline. And for the single sequence use case, we can also achieve the performance that is on par or faster than the existing MLC chat app on all the supported platforms. And I think this pretty much concludes my update of MLC Serve today. And yeah, that's it for me. And thank you for listening.
Thank you, Rihang. Are there any more questions?
Hi there. I have one question.
Yeah, sure.
You mentioned that we will the MSC LL will transition to the new REST API. I'm curious about the what is the main difference between the old API and the new APIs? I
think basically the previous API, it is based on the previous runtime used using chat module, and that basically mean all your requests will be processed sequentially. Say if my server receives like 10 requests at the same time, then it has to probably the server has to figure out an order and process the request one by one. But by switching over the REST API to the MLC server pipeline, that means if, say, my server receives 10 requests at a time, it can batch all the requests together, and that will save pretty much time. And yeah, I think that's the main difference from say the user experience side.
Thank you, John.
Yeah, thank you.
Any further questions?
I have another question. If folks,
It's fine.
I'm curious about the JSON mode. You mentioned that it seems the JSON mode is already or it's gonna be merged soon. Based on our experience in the MSC optimal MSC LLM serving, seems we found the JSON mode is not vectorized. That means the performance is not very good. I'm not sure if you guys have some insights or comments on the JSON mode about here.
And can I have a question? You mentioned about the vectorized. Am I misheard or?
Oh, we had I think it's in the we made the JSON mode performance issue in the Optimal's MLC LLM. In that JSON mode, some of the logic are not vectorized. There's some performance issue, but I don't know if you have this the same issue.
Okay, I think for our implementation of the JSON mode here, that would be we process the law, like the legal tokens that's conforming the JSON format in a finite machine, the finite state machine. And I think that would help accelerate the overall process of JSON. Yeah, and yeah, definitely we will benchmark the overall performance on the JSON format. But right now it is still ongoing.
Thank you. I see.
Very good. Are there any other questions? If not, we have plenty of time remaining. So the floor is open to any more discussions that anyone would like to propose. Anything at all. We have half an hour more blocked out. This is an open forum.
Hey, any update on TVM Con this year?
Yeah, so as of now, we have not yet planned for TVM Con. I feel like likely if we are gonna do it, it's not gonna be Q1. Yeah.
Okay.
Thank you, Tenchi. Are there any other topics that anyone would like to raise? Granted, of course, raising without, preparation in advance. Nevertheless, those can be fun discussions.
I wanted to make sure you guys got your topics out of the way. So I'm Jonathan. I've been using MLC. It's been fascinating to delve into what you guys have put together. Now, the challenges for me have been about either running MLC in the cloud, challenges around which build compile / TVM / MLC area it's kind of happening. I saw that there was an educational kind of angle to MLC, but it doesn't really have operational technical details. So like how-to guides of hosting an MLC on a CUDA AWS instance, for example, would have gone a long way to save me some time. And I was wondering if like educating the public is kind of the thing you guys have been tracking. I'm surprised MLC is now more popular than Llama CPP.
That is
Yeah,
a
I think
great
that
question.
there are two folds of the question. The one fold question is, the overall documentation of TVM itself, and this is something that actually we are actively working on, given that TVM lands on the main, so there will be document update on there. And in terms of the MLC itself, so one of the things that that the kind of hurt us in the beginning is that we kind of gone through several rounds of transitions on enabling all those new features. And these are going to be stabilized. Hopefully, some of the official documents will become more, actionable in some sense. And if you have suggestions on questions, feel free to open issues and we can try to bring. And these should be documents on the MLCRM itself. Yeah.
Gotcha. I already saw you deprecated the CLI from the C++ one. That made a big improvement because like I didn't know what Delta was what Delta was causing my newfound failure.
Yeah.
But I guess as a customer journey, if I can share something with you, it would be I would never feel comfortable like asking because I don't know a lot of things on a lot of areas, and there's so many moving parts that I kind of just slave away in the corner until like something works or I get frustrated and leave it. One good example is like a Q3 F16 version of the Mistral only failed on my Intel Mac, but passed on my Mac OS with the M2 Ultra. Now, I got a little bit ambitious and kept debugging the heck out of it, and I found out it was the prefill size. If it's 128, then it like works, and if it's not, I dropped a short PR on that. But what I'm trying to describe is like the chances of me like filing an issue or asking you guys is slim because I don't know if it's a TVM issue, if it's a compilation issue with my specific hardware or some CUDA driver issue. And I've hit all of those, and I'm like listing them out because I would grok GitHub issues, and then when I couldn't find them, I'll just keep trying to fiddle with it. I don't know if this is helpful to you guys, but it's something you're up against in getting popular with MLC.
Certainly, I know. One of the things that we would like to enable is having some of a regular testing of models on the common set of hardware. So hopefully, Intel Mac is challenging because there are kind of like different issues on getting metal up. But the latest version, hopefully, we'll be able to get them tested thoroughly on the new models. Yeah.
Okay. I'll leave room for somebody else to ask questions, but if there's some time at the end, I would love to ask one technical challenge that I ran into.
Any more questions? Because I think, Jonathan, you're not in any danger of running out of time.
Well, actually, now that I think about it, this could be what's missing, like sort of lab hours for MLC.
Good idea.
Okay. I'm gonna preface my next question by saying, please don't think I'm dumb. What I'm trying to do is essentially embedding with MLC is sort of my focus area because I'm trying to parse all RSS feeds on the internet and then like chunk them up to fingerprint like an interest thing on one side, and then create embeddings on the user in device on the other side. So then I can have like a privacy respecting recommender system that's prioritizing your personal interests from emails, like things that are on your phone. That's high level. Now bringing it down to earth is basically large scale embedding. I've tried MPNet with Sentence Transformer and it works pretty fast on CUDA on AWS. Not the greatest result, but I saw that the E5 base model that I mentioned a little bit ago has some really good performance on like semantic proximity. And this is where my understanding kind of tapers off. And if you don't mind, I'm gonna share my screen with you. Computer kind of froze on me. Gotta hate it when it's always when you're ready to
Oh
get
no,
started.
always in a meeting.
Maybe.
Well, take your time.
If anybody has a thought in the meantime, you can take some of the pressure off.
I'll just introduce myself. My name's Eric. This is my first meeting, and just thought I might find a way to contribute in some way. So I'm glad to be here.
Thank you,
Welcome.
Eric.
Good to
Welcome.
have you
Yes.
here.
All right. Well, if we want to kill some dead air, here is a terrible joke, shamelessly stolen from a dad joke channel I'm on. I'm told telling jokes is a great way when you have this kind of dead air. So, are glass coffins going to be a success? Remains to be seen. Okay, I have even worse ones. Jonathan, do you think it will actually share your screen?
Hit me. I mean, I'm going to wait for one more for sure.
Okay. I won't tell more jokes.
Okay, I just have to reopen now. I think I'll be right back.
I sympathize. This happens to me all the time.
No. Okay, here we go. Okay, so what I'm trying to do basically is snoop at whatever Mistral model is doing and try and set it up so that the E5 BERT E5 Mistral 7B instruct. So from what I understand, what they did was they just lopped off the LLM head, and then that's how the model came to be. So in other words, if we look at how Mistral looks, there's the model weight. And if I hadn't changed anything initially, this is what the model looks like. So one of the first issues that I ran into when I'm trying to do the, basically the convert weight step is that it has issues with the names. So it likes model.layers. Is that hard coded somewhere? That's one thing I got stuck on. It's I looked at the model.py.
I think for matching the weight names, it's taken care of by you see how there's Mistral model, there's also Mistral weight.py, I think.
Yeah.
Under the Mistral folder. I think we do some manual changes of name mapping over there. Oh yeah, Mistral loader. Yeah, maybe you could trace a bit the code here. Yeah, I don't have I don't know where to change at the top of my mind, but I think this is the file to go to.
Yeah.
Yeah, and you mentioned that there's no LM head, so probably for the Mistral model, you might want to take out the LM head portion, I guess.
Which is my next question. If I just hardwire it out of the head, will I be good? So basically, commented that out, and then the other one, I just returned the hidden state, basically.
I think, yeah, it might be enough.
Okay.
Yeah, like
So
you still need to be able to get a runtime support because right now we are outputting tokens, right? You want embeddings effectively. So
yeah, that's the thing that I have to ramp up on. I saw that they did this. Can you use a MLC model as a tokenizer just like PyTorch? Like, is this possible with MLC models?
So likely what you need is you need the embedding out and I feel like, in this case, if you want local runtime deployment, then we need to do something on the runtime end to be able to get you the embedding. Yeah.
I see. I tried to look at the Llama get embedding implementation, but this doesn't just lop off the bottom layer, it lops off the last node, like an EOS key at the end, to be able to decide and capture the whole sentiment associated with the next word prediction task is being used to represent the actual input sequence. Okay, so my takeaway from this is I'm a little out of my depth, but I was also curious why the model names weren't just read off the actual like model files.
Are you saying the weight name differs from the ND, like the JSON?
Yeah, like so if it's layers, it doesn't like it. It needs to be model.layers. You see model.
I think it might be like different variants, like different Mistral variants have different names, and we had to just pick one. I think that's the.
It is in the binary though, right? Like is Torch doing something different, or is just reading the binary?
Sorry, what was the question?
Like the models.keys,
right,
basically prints out whatever is in the index, but without actually ever looking at the index.
Right.
And ideally, this would have had the same, it would have come up with model token.weight, but sorry, it wouldn't have appended the model dot if it was reading off the binary. So if I was being adventurous and I could create a PR with like reading off the names from the binaries make a difference?
I'm slightly not sure.
Like my question, or maybe let me rephrase it. So pristine Mistral 7B expect model.embed tokens.weight as the keyword.
Yes.
Right?
Yes.
And this will match if we read the model path for Mistral as well. Like it would have outputted the same thing. Here, why don't I?
There's another model path lower inside the folder.
I see. Yeah. So I would expect it to write model.layers in this case, right?
Okay.
And then in the old case, in the new one for the embedding version, I don't know why they felt like doing it, but they got rid of the model dot in the layers names.
I see. Yeah. So I think in this case you might need to change Mistral loader.py yourself to match it up.
Okay. Would it be a useful addition to actually implement like a binary reader to get the names as opposed to
I see your point. So instead of like manually changing it, you do it Like,
Yeah, that way the
right.
Mistral can be applied for both.
I guess it
It's
could be
hard to do it generically. Like for different models, they have different conventions, mainly because we like, you kind of need a certain convention to be able to map to different layers.
I
So
see.
certain convention need to be assumed in here. Yeah.
So not a lot of gain by just being able to, I don't know, whatever dynamic. Got it. Okay, so model loader, Mistral, you've given me a green light on chopping it off. This is a pretty dumb question, but when I generate embeddings using an MLC, I had to look at your serving code. It would be nice if it was like exposed out, but basically, where do I? This is kind of just a general question as saying like, so embed text, is that, I saw that was a llama model file. And then I try to kind of like see if I can extend that in some way, but is embedding normally just lopping off the bottom part of the model?
I think this embed here might mean the first layer of the first
Okay.
embedding layer instead of the entire model except the LM head. I'm not
So
too sure.
in this case, like there's not yet a sentence embedding or embedding model support, and I think that is something we still need to work on. Yeah. That is
Okay.
just like a embedding lookup. If you
This is where I got stuck, as in like it says it's in chat module embed, create chat module embed. I didn't know where to follow that after just to see how that embedding function was built. Does that mean it's in the TVM world?
Yeah, so this is something this is a function that TVM creates, but likely it's not something you're looking for, because you are looking for the final sentence embedding, and that is something that we still need to build support for in this case.
Yeah, I was trying to get inspiration from an already implemented embedder code to see how to not be so gruesome, because I think the weight's changing and then an embed function. Okay. Anyways, thank you so much. You've 10x'd sort of my discovery in like 10 minutes. So I appreciate all the information you've given me so far.
All right, lovely. We have about 10 minutes remaining, so if there is any further topic, this is a good time to raise it. If not, we can adjourn. I think it's definitely a good idea. We should definitely stew on the idea of having indeed some kind of occasional lab session, or at least some kind of live forum for technical questions. I'm not sure the open development meeting is not to imply that this was not a good use of our time. It was, but I'm not sure this is the most maybe the most accommodating format, the friendliest format, especially since it's all recorded. But definitely a good idea to have a lab hour. That could be useful. But I think I will leave that pondering that to the people who actually contribute to MLC most often. I contribute to TVM main, not so much MLC, so I don't want to speak on their behalf. But very good idea. Okay, but if there's no further topic, we can adjourn. Thank you, everybody. I look forward to seeing you at future meetings, perhaps, and we will schedule at some point the next vertical focus meeting. Thank you, everybody.
And thank you guys for being awesome and all your help so far.
Thank you.
Seeing you.